Hi there, this is Mr. Schnetzius. In this video, we're going to go over numbers 31 to 45 on the North Carolina end of course geometry assessment. Number 31 says, Kevin's teacher gave him the following pieces of cardboard, 2 equilateral triangles, and 4 squares. Which polyhedron can Kevin build with some, this is the important word, or all of these pieces? Well, here are some pictures of our different answer choices. As you can see, a rectangular prism has more than 4 squares and no equilateral triangles, so that is no good, so B is out. A triangular pyramid has 4 triangles and he only has 2, so that is out. A square pyramid has 4 lateral triangles, so that is out. So he would want to build the triangular prism using 2 of the triangles as his bases, and then he would only need 3 of these 4 squares, as long as this was 4 inches. Those were all the same all the way around. He would just need to be sure that this length right here was 4 inches, and he would be set. Number 32 says circles P, Q, and R are shown below. The diameter of circle R is 22. What is the length of segment PR? So from P clear all the way over to R, which I'm highlighting here, and eventually I'm going to highlight it correctly. There we go. Well, we need to know the length of each part of this segment. Well, the length from P to the boundary between circle P and circle Q is a length of 5. In circle Q, the radius is 9, no matter if we draw it here to the left or here to the right. And in circle R, if the diameter of the circle is 22, then the radius is 11. So the length of segment PR is going to be made up of a 5-unit length plus 2 9-unit lengths plus an 11-unit length, which is going to be a total length of 34, which gives us B. Number 33 says, based on the coordinates E and -2, -3, F, G, H, I, and J, which best describes polygon E, F, G, H, I, J? Don't get too freaked out about this problem. Concave polygons are not going to be tested on the final exam. I just wanted to give you some practice plotting points maybe and remind you of some other vocabulary. Okay. So what is the difference between equiangular and equilateral? Well, equilateral means the same, all the sides are the same length. Equiangular means all the angles are the same measure. So we can pretty clearly see that this angle right here is larger than this acute angle and these obtuse angles, so it is not equiangular. It is equilateral, and if you want to look up what concave polygons are on your own, then more power to you, but that will not be covered on the final exam, so we're not going to go into it here. Number 34 says, what is the inverse of the statement in the box? If a polygon is regular, then it is convex. Well, this is a good way to review conditional statements and their ways that we can change them. The conditional statement is written in the form if P, then Q, where P is the hypothesis and Q is the conclusion. The inverse of that conditional statement is if not P, then not Q. You take the hypothesis and you negate it, and you also take the conclusion and negate it. So we're looking for an answer where if a polygon is regular comes first and then it is convex comes second, except instead of saying that a polygon is regular, we say if a polygon is not regular. That's what A has. B does not have that. C has that. D does not have that. So we not only wanted to say that if a polygon is not regular, we also wanted to say that it is not convex. That's what A says. C leaves out the not, so that's why we are going to choose answer choice A. Number 35 says which parts must be congruent to prove triangle PQR is congruent to triangle PSR by SAS. Well, remember that means side, angle, side. Okay, so it looks like we know that segment PR belongs to both triangles. So we need either segment PQ and segment QS, segment PQ and segment PS are congruent and the angle in between, or segment QR and segment RS and the angle in between. Well, angle Q and angle S are not in between either of those pairs of sides. We're going to get rid of answer choice A and answer choice B. Let's just assume that C is the answer, okay? Angle QRP is congruent to angle SRP, and segment QP is congruent to segment SP. Well, that would not be side angle side because the angle is not in between the two sides. That would be side angle, which is not what we are looking for. So let's try answer choice D. Angle QPR is congruent to angle SPR, and segment QP is congruent to segment SP. Hey, that's side angle side. That's why the answer is D. So I've got a picture to help us out here with number 36. A plane intersects a sphere that has a radius of 13 centimeters. So here's the big sphere. The radius of the sphere is 13 centimeters. The distance from the center of the sphere to the closest point on the plane is 5 centimeters. So here's the plane. This says P right here because that's the plane, and then it's intersecting the circle. Sorry, it's intersecting the sphere to form this circle. And then it says, what is the radius of the circle that is the intersection of the sphere and the plane? So in other words, what is this value right here? Well, since we measured distance at a right angle, we are going to solve this question using Pythagorean theorem. So that's going to be 5 squared plus r squared equals 13 squared. So 5 squared is 25 plus r squared equals 169. And now we want to take 25 away from both sides. So that gives us r squared equals 144. So we can take the square root of both sides, and we are going to get that r is 12, which is why the answer is C, 12 centimeters. Number 37 says triangle PQR shown below will be rotated 180 degrees clockwise about the origin. Which rule describes the transformation? Well, first, let's get the coordinates for P, Q, and R. P is at 1, 3. Q is at 3, 5. And R is at 5, 1. Now, when it says that we're going to rotate 180 degrees about the origin, that means that we're going to draw a straight line through the origin onto the other side of the origin, and point P is going to be here at -1, -3. That's going to be point P prime. Why is that what we get when we do the 180 degree rotation about the origin? Well, the segments showing us this angle have to pass through the origin. And this is a straight line because the measure of a straight line is 180 degrees. So if this is xy, and this is x prime, y prime, how did we change x and y to get xy, x prime, y prime? Well, A says that they stay exactly the same. That is false. B says we keep x and y the same, but we add a negative sign to x. We did add a negative sign to x. We did change the sign of x, but we did it to y also, which is why D is actually the correct answer. We changed the sign of x, but we also changed the sign of y, so 1, 3 changes to -1, -3. Number 38 is about a vertex matrix. We're not going to worry about that. So we're not going to worry about these answer choices. This is a reminder, though, that if you translate 3 units left and 4 units up, and you want to show that with transformation notation, that would be xy changes to x minus 3, comma, y plus 4. Number 39 says triangle PQR has vertices -1, 3 at P, Q, 1, 2, and R, -2, -1. So we've got those graphed over here. When triangle PQR is reflected over the line y equals -2, which we have graphed down here, what are the coordinates of P prime? Well, if this is a reflection, we need to measure how far away is P from this line of reflection. That's 1, 2, 3, 4, 5 units away. So we want to start here and go 1, 2, 3, 4, 5 units onto the other side. And that gives us the point -1, comma, -7, which is why we get the answer B. All right, number 40 again has a vertex matrix that is not going to be on the final exam. What I did want to show you is these are the coordinates of triangle MNO and how we could reflect those over the x-axis, just like we did in number 39. Take this point. If it's 1, 2, 3 units below the x-axis, it's going to go 1, 2, 3 units above the x-axis. There's M prime. Same thing for point O. It's 4 units below the x-axis, so it has to go 4 units above the x-axis. There's O prime. Point N is 2 units above the x-axis, so it needs to go 2 units below the x-axis. That's point N prime. And now we get this very lovely triangle that is congruent to the pre-image triangle, and that is our example of a reflection across the x-axis. Number 41 gives us a right triangle and asks us what is the approximate value of h. Well, since this angle here measures 60 degrees, we have a 90-degree angle here. That means that we're going to have a 30-degree angle up in the top. And on your star geometry chart, you're going to get the values for a 30, 60, 90 triangle. Across from 30 degrees goes x. Across from 60 degrees goes x times the square root of 3. And across from the 90-degree angle goes 2x. So if 2x equals 200 meters, divide that by 2 and you get x equals 100 meters, which means that h, if that's going to be x times the square root of 3, we can substitute 100 meters for x, and that's going to be 100 meters times the square root of 3. So we can use our calculator to figure out about what that's going to come out to. 100 times the square root of 3 gives us 173, which gives us answer D. Number 42 says segment KM is an altitude of triangle JKL, and segment KM is congruent to segment JM. The measure of angle LKM is 55 degrees, and the measure of angle of segment ML is 12 centimeters. Well, if we can figure out the length of segment KM, then we'll know the length of both sides over here, and we can use what we know about isosceles right triangles to help us finish the problem. But first, over here, we need to use trigonometry to solve for the measure of segment KM. Segment ML is opposite the 55-degree angle. Segment KM is adjacent to that 55-degree angle, so we want to use tangent. It's going to be the tangent of 55 degrees equals opposite divided by adjacent. We can solve this equation pretty easily if we put the tangent of 55 degrees over 1, and now we cross multiply. So we've got the tangent of 55 degrees times x equals 12 times 1. That's pretty easy. That's just 12. We can divide both sides by the tangent of 55 degrees. So if we put 12 divided by the tangent of 55 degrees, that'll tell us how long segment KM is. So as a decimal, that comes out to about 8.4. Now notice that 8.4 centimeters is one of the answers, but that's not the answer to the question. That tells us how long segment KM is. We want to know how long segment JK is. Well, if both of these sides are the same in a right triangle, that means that the two acute angle measures are the same too, so that's a 45, 45, 90 triangle. If these two legs are labeled L and L, and this side is L times the square root of 2. So the length of segment JK is going to equal 8.4 centimeters times the square root of 2. Let's see what that comes out to be. As a decimal, that's about 11.87 or about 11.9 centimeters, which comes out to be B. Number 43 says a number line is shown below. Point P will be picked at random on segment EK. What is the probability that P will be on segment FK? Well, probability is a ratio of part over whole. So in this case, it's going to be the desired length over the total length. For us, that means the length of segment FK divided by the length of segment EK. So how long is segment EK? Well, from 0 to 5 is the length of 1, 2, 3, 4, 5. But what about the length of segment FK that we're wanting to find the probability for? That's the length of 1, 2, 3, 4 units. So that gives us an answer of 4 out of 5, or C. 44 says Katie, a gardener, needs to put grass seeds on the triangle formed by the 3 roads below. Each side of the grass triangle is 350 feet long. If one bag of seed covers 10,000 square feet, how many bags will Katie need to buy? Well, this is an area problem, and the way we find the area of a triangle is 1/2 base times height. So we need to find the height of this triangle. But we've seen this before on this assessment. If this is an equilateral triangle, then it has to be an equiangular triangle as well. All 3 of the angle measures of the equilateral triangle measure 60 degrees, but this one gets split into 2 30-degree angles, which means underneath we can draw a 30, 60, 90 triangle. So the hypotenuse is going to be 350 feet. Across from the 30-degree angle is going to be half of that, 175 feet. We want to know what the height is, which is across from the 60-degree angle, which we label x times the square root of 3. If across from the 90-degree angle is 2x and across from the 30-degree angle is x. Well, the height then is going to equal 175 times the square root of 3 feet. We just substitute 175 for x. So now to find the area, that's going to be 1/2 times the length of the base, 350 feet, times the height, 175 times the square root of 3 feet. And let's see what that comes out to. 1/2 times 350 times 175 times the square root of 3. So that's about 53,000 square feet. And you need to be careful here because we want to do more than just divide this by 10,000 square feet. How many bags will Katie need to buy? Well, the tempting answer would be 5, because if we divide this, we're going to get 5.3. But if she only buys 5 bags, she's going to have 3,044 square feet left over. So 5 bags is not enough. She needs to buy 6, which is why the answer is B. Number 45 says, what is the approximate surface area of a right hexagonal prism with a base perimeter of 96 meters and a height of 10 meters? Use S equals AP plus PH, where A is the apothem of the base, P is the perimeter of the base, and H is the height of the prism. So it's nice on this problem that they give us the perimeter of the base, they give us the height. We need to solve for the apothem. We need to solve for what this apothem right here is. Well, if the perimeter is 96 meters, if we divide that by 6, that'll tell us the length of one side, which is 16 meters. So each of these sides measures 16 meters. We've seen this before on this assessment. Each of these central angles is going to measure 60 degrees. So we can draw out that equilateral triangle that we can use to solve for the apothem. We're looking for this length right here. We know that these are actually equilateral triangles inside the hexagon. Why is that? Because each of these radii are congruent. So if this measures 60 degrees at the top, there's 120 degrees left over for these two congruent base angles. So these are each 60 degrees. Well, now we can split this up to make a 30 degree, 60 degree, 90 degree triangle, where this hypotenuse is 16 meters, this length is 8 meters, and the length across from the 60 degree angle is going to be x times the square root of 3 if 8 is x, so that's going to be 8 times the square root of 3 meters. So now we finally got the apothem that we're looking for. So this surface area is going to be the apothem, 8 times the square root of 3 meters, times the perimeter, 96 meters, plus the perimeter, 96 meters, times the height. So let's put that whole thing into the calculator. 8 times the square root of 3 times 96 plus 96 times 10 And as a decimal, that comes out to be 2,290, which is answer choice B. All right, that's it for this video. One more to go. Good luck studying for your final exam.